Chemical bonds and equations. Types of chemical bonds. All around us, the world are made out of compounds that are bonded together to create things that make life on Earth possible. In this section, we're going to talk about the influence that types of chemical bonds have and how compounds come together. Now remember that a compound is a substance made of the combined atoms of two or more elements. An interesting observation that you're going to start noticing is that the compound formed from elements often have properties that aren't anything like those of the individual elements. One such compound would be sodium chloride or salt. Now, breaking it apart, sodium by itself is a shiny, soft, silvery metal that actually reacts violently with water. Chlorine by itself is a poisonous, greenish, yellowish gas. But would you have guessed that these two elements, once combined, make a compound that is just ordinary table salt? The properties of table salt are, as you can see, are much more different than those of sodium and chloride when they are by themselves. Now the chemical symbols Na and Cl represent the elements of sodium and chlorine. When written as NaCl, the symbols make up a formula. And a formula is a chemical shorthand for a compound, in this case, sodium chloride. A chemical formula tells what elements a compound contains in the exact number of the atoms of each element in that unit or compound. The compound you are probably most familiar with is H2O, more commonly known as water. This formula contains the symbols H for the element hydrogen and O for the element oxygen. But notice that the number 2 is written after the H for hydrogen. That number 2 represents that there are 2 molecules of hydrogen. This table looks at some familiar compounds and shows you their chemical formula. Let's take a look and see if you can determine the elements and the exact number that make up each formula. The top compound here is acetic acid, also known as vinegar. Looking at the chemical formula, you first want to determine the elements that are present. Here we have hydrogen, carbon, and oxygen. The next thing you want to notice is the subscript number written after each element symbol. Subscript means written below, and this subscript is going to tell us how many atoms of the element are in a unit of that compound. If a symbol has no subscript, then the unit contains only one atom of that element. Now, looking back at acetic acid, we can see that there is one atom of hydrogen at the beginning of the chemical formula, 2 atoms of carbon, 3 again of hydrogen, and 2 of oxygen. Why don't you take some time here to determine the chemical formulas for silicon dioxide, hydrochloric acid, and sucrose. To help you throughout this section, I want to go over all the parts of a chemical formula so that you can recognize and understand them. Now, in the front, if there is a large number for the chemical formula, this is called a coefficient. A coefficient tells you the number of units of each substance. Here we can see that there are 2 molecules of H2O since the number 2 is the coefficient. We've already talked about the subscripts, which are the lower numbers, and these again represent the number of atoms in a molecule of a particular element. But there is also sometimes a superscript, and this number is usually higher and sometimes has a positive or negative charge. This superscript represents an oxidation number. And what an oxidation number tells us is how many electrons this compound has gained or lost. Now, sometimes they gain or lose electrons because atoms form compounds in order to become chemically stable. An atom is chemically stable when the outer energy level is complete or full. When atoms gain, lose, or share electrons, an attraction forms between the atoms, pulling them together to form a compound. This attraction is called a chemical bond. A chemical bond is the force that holds atoms together in a compound. We're going to learn more about how these bonds are formed. Now, we've talked before about how atoms want to lose or gain electrons to get a stable energy level. An atom that has lost or gained electrons is called an ion. An ion is a charged particle because it now has either more or fewer electrons than protons. The positive and negative charges are not balanced, and it is these electric forces between oppositely charged particles, such as ions, that hold compounds together. Some of the most common compounds are made by the loss and gain of just one electron. So what determines if an atom is gaining or losing electrons? What you want to look at are the electrons in the outer shell of the atom. If you look at elements in group 1 on the periodic table, you will notice they all have one electron in their outer shell. If they were to lose that one electron, well, now their outer shell would now have 8 electrons and it would be much more stable. Now look at another element in group 17. Group 17 all have 7 electrons in their outer shell, and we know that they need 8 to be stable. So those elements may gain an electron in order to be stable. When ions attract in this way, a bond is formed. An ionic bond is the force of an attraction between the opposite charges of the ions in an ionic compound. In an ionic bond, a transfer of electrons takes place. If an element loses electrons, one or more elements must gain an equal number of electrons to maintain the neutral charge of the compound. Ionic bonds can form between metals and nonmetals. Now, some atoms are unlikely to lose electrons. For example, those elements in group 14 of the periodic table have 4 electrons in their outer shell. They would either gain or lose 4 electrons in order to have a stable outer energy level. The loss of this many electrons would take a great deal of energy. Therefore, these atoms become more chemically stable by sharing electrons rather than losing or gaining them. The attraction that forms between atoms when they share electrons is known as a covalent bond. A neutral particle that forms as a result of electrons sharing is called a molecule. Covalent bonds occur between nonmetals. All right, let's take a break. It's time to show what you know.